Let's start by looking under the hood of the human brain, because when we talk about focus, we're not just talking about a mindset or an idea. We're talking about a very real, very physical mechanism that can be located, measured, and, most importantly, trained. At the center of this mechanism lies a region of the brain called the prefrontal cortex. This is the area right behind your forehead, and it's responsible for what we call executive function: planning, decision making, suppressing impulses, and yes, focusing. But the prefrontal cortex doesn't operate in isolation. It relies heavily on signals from other areas of the brain, especially from a small but powerful region in the brainstem known as the locus coeruleus. This region is the brain's main source of norepinephrine. A neuromodulator that acts like a chemical signal booster. When norepinephrine is released in appropriate levels, it heightens alertness and selectively amplifies neural activity in specific circuits. In this case, the ones responsible for directing attention. This is where the concept of the focus switch comes into play. Think of the locus coeruleus as a volume knob. When it's too low, your attention drifts, your thoughts are cloudy, and you feel tired or sluggish. When it's too high, your thoughts race, you're jittery, and it's hard to hold on to a single idea. But when the volume is just right, moderate, sustained norepinephrine release, you hit the sweet spot of calm, alert focus. That's the neurological state where deep work happens. Now, there's a second chemical player that's equally important here, acetylcholine. This neuromodulator works more like a spotlight. While norepinephrine enhances overall alertness, acetylcholine helps to narrow your attention. It sharpens the signal to noise ratio in your brain, making certain neurons more responsive while dampening irrelevant inputs. When acetylcholine levels are high in the prefrontal cortex and sensory pathways, your brain effectively says, "This is the thing we're doing." Everything else can wait. Understanding this dual system, norepinephrine as the volume knob and acetylcholine as the spotlight, gives us the biological framework for what we're calling the focus switch. When both systems are engaged at the right level, you experience a state of directed attention. You're not just awake, you're aligned. You're not just alert, you're absorbing, processing, and producing at a high level. This system didn't evolve for spreadsheets or writing code. It evolved for survival. Think about our ancestors tracking prey across vast terrain, scanning for slight movements, subtle patterns in the environment. Their survival depended on the ability to lock attention onto one target for hours at a time while filtering out distractions like wind, heat, or noise. The focus switch is primal and incredibly powerful. It's still in you and it's accessible. But in our world, it's constantly being overridden by technology, overstimulation, and fragmented attention. Every notification, every swipe, every email trains your brain away from sustained focus and toward novelty seeking. What's fascinating is that these neuromodulators norepinephrine and acetylcholine are not fixed. They can be influenced by behavior, by environment, and even by thought. For example, studies show that mental effort alone can trigger activity in the locus coeruleus. Simply deciding to pay attention increases norepinephrine release. That's important because it means intention matters, but the effect is weak unless paired with the right behavioral and physiological tools, which we'll talk about shortly. Another key detail here is these neuromodulators don't act instantaneously. There's a ramping process. When you engage in an attention-demanding task, norepinephrine rises quickly, but temporarily. If you push through the first minute or two, the system stabilizes and the brain enters a more locked-in state. This is why the first few minutes of work always feel like resistance. It's not a psychological block. It's a neurological threshold. Also crucial to understand dopamine. The motivation molecule plays a supporting role. It doesn't directly create focus, but it strengthens the networks that do. When you receive even a small reward, completing a task, checking off a box, dopamine reinforces the circuit that just executed that behavior. That's why systems like Pomodoro timers or micro goals are effective. They work with your neuromodulatory system, not against it. And this leads us to the most powerful realization. Focus isn't something you wait to feel. It's something you can initiate, like flipping a neurological switch. You need to create the right chemical conditions in your brain. That begins by understanding the levers norepinephrine for general arousal, acetylcholine for precision, dopamine for reinforcement. So when you sit down to focus, know this, your brain is not working against you. It's wired to focus, but it needs a signal. That signal isn't magical and it isn't emotional. It's physiological, it's biochemical, and it's entirely under your control once you know how to trigger the systems. Now that we understand how the brain generates focus through norepinephrine and acetylcholine, the next question is this: how do we activate these systems when we need to? How do we take control of the switch and deliberately flip it, even when we don't feel like it? The answer lies in specific science-backed protocols, actions that send clear signals to your nervous system that it's time to engage, to narrow the field, and to lock in. One of the fastest ways to initiate the focus state is through the eyes. Why? Because your visual system is the most direct path into the brain's attentional networks. What you look at and how you look at it immediately affects your state of arousal. This isn't metaphorical. Your eyes are part of your central nervous system. They're essentially two pieces of brain tissue that have been pushed out into the world, scanning and sending data back into your skull. Here's what that means practically when you direct your gaze to a single point in space, what we call visual anchoring. You engage a mechanism called the reticular activating system, which signals your brain that it's time to pay attention. When you narrow your gaze, you narrow your mind. and it works in reverse twos. When your eyes are darting around, shifting, scanning, your brain stays in exploration mode. You're telling your system, stay open, stay unfocused. So if you want to trigger the focus switch, begin with a still, focused gaze on a single target. It could be your screen, a document, a point on the wall. What matters is not the content, but the action of holding that gaze for 30 to 60 seconds. You'll notice a subtle shift. The system begins to calm, thoughts quiet slightly, and a kind of tunnel vision sets in. That's not a psychological trick. That's your brain loading acetylcholine into the appropriate pathways. Once the visual system has cued the brain, the next protocol involves breath control. Your breathing patterns are deeply linked to your state of focus. Shallow, rapid breathing signals stress and scattered energy. Long, deliberate exhales signal calm and readiness. But the most effective breathing pattern for shifting into focus is called cyclic physiological sighing. It's a double inhale through the nose, followed by a long exhale through the mouth. When you perform 2 short inhales, you inflate the tiny sacs in your lungs called alveoli, which helps offload excess carbon dioxide. That's important because high call can increase feelings of mental fog and internal noise. The long exhale activates the parasympathetic nervous system, dropping your heart rate and reducing physiological noise, which makes it easier to direct cognitive energy inward. This isn't theory. It's hardwired. You're telling your body, I am calm, I am alert, I am ready to engage. Layered on top of breath and visual anchoring is timing. Not all moments in the day are created equal. Your brain operates on a cycle called the ultradian rhythm, roughly 90 minutes long, during which energy and alertness rise and fall. The first 4 to 6 hours after waking, especially if you've gotten bright light exposure in the morning, are typically the most neurologically optimal for deep focus work. This is when cortisol is highest, dopamine is most responsive, and the brain is primed for effort. So when you're trying to engage the focus switch, stack your efforts. You do it within those high energy windows after light exposure, following a bout of movement, or even a cold shower. Anything that increases adrenaline just slightly without creating overstimulation. And once you're in that window, eliminate context switching. One of the fastest ways to shut off norepinephrine and lose your focus is to jump between tasks, tabs, or inputs. Each shift introduces novelty, and novelty disrupts the neurochemical balance we're trying to establish. Then there's posture and movement. When you sit upright, shoulders slightly back, spine extended, you activate systems in the midbrain that increase readiness and arousal. This isn't about looking confident. It's about leveraging the body to brain feedback loop. The same circuits involved in standing alert on the battlefield or in a competition are engaged when your posture signals, I'm on. If you slump or lean back, you're signaling to your brain that you're in recovery mode, not go mode. Another powerful but often overlooked tool is self-directed speech. When you mentally or verbally say, "Now I focus," or "This is the task," you activate prefrontal circuits that sharpen your intent. There's real data showing that internal speech modulates activity in brain regions responsible for goal maintenance and task persistence. The effect is subtle but cumulative. It increases over time as your brain begins to associate certain phrases with neural engagement. Finally, consider setting a cognitive entry point. A very simple version of the task that requires minimal effort but gets the gears turning. For a writer, it might be opening the document and rereading the last paragraph. For a designer, it might be adjusting colors or reviewing an old layout. These small wins create what's called behavioral momentum. You don't wait to feel motivated. You just begin. The beginning activates norepinephrine. The engagement sharpens acetylcholine. The reward triggers dopamine. All of these protocols, visual anchoring, breath regulation, strategic timing, posture, internal language, and momentum, are ways of signaling to the brain now is the moment. The focus switch flips when your biology aligns with your intentions. The goal isn't to force focus. It's to prepare the system so that focus becomes the most natural thing to do. This is how elite performers train. This is how scientists, creators, and leaders sustain depth in a world that's constantly pulling them toward shallowness. And the key is not magic. It's protocol. It's precision. It's you learning how to engage the systems you already have access to. Let's now talk about what happens outside the brain, because while your neural chemistry is critical, it's your environment and behavior that often determine whether the switch of attention actually gets flipped or stays stuck. Your surroundings, your posture, your habits, they all act as silent cues, and your brain listens. It takes instructions from your environment all the time. What we're going to do now is take control of that conversation. The first lever is light. Light isn't just something you see. It's something that instructs your brain. Your retina has specialized cells called intrinsically photosensitive retinal ganglion cells. These cells don't help you see objects. Instead, they communicate directly with the hypothalamus, regulating your circadian rhythm and influencing the release of neuromodulators that govern alertness. When you expose yourself to bright overhead light, especially in the morning, you trigger a rise in cortisol and norepinephrine. This combination primes your brain for focus and effort. Dim lighting or lighting from below, in contrast, communicates to the brain that it's time to wind down. That's why working under warm, cozy light may feel pleasant, but rarely leads to deep focus. If you're trying to activate attention, brightness matters. Direction matters. The time of day matters. These aren't aesthetic decisions. They're biological ones. Next, consider sound. Your auditory system is deeply tied to your autonomic nervous system. Sharp, unpredictable sounds like notifications, doors slamming, or someone talking in the background can spike your heart rate and jolt your attention circuits, even if only for a fraction of a second. These micro interruptions accumulate. They introduce friction. Every time your brain has to reorient, it burns energy. So the goal isn't silence. It's predictable auditory input. This is why white noise, pink noise, or low-frequency binaural beats can be effective. They provide a steady auditory backdrop that drowns out distracting peaks and helps you lock into a task. But music with lyrics, variable tempos, or sudden shifts, those activate the brain's language and prediction systems, pulling resources away from whatever you're trying to focus on. If your goal is deep work, you want your auditory environment to support, not compete. With your attentional bandwidth, another key lever is posture and movement regulation. You might think of focus as a purely mental activity, but your body position plays a huge role. Standing tall or sitting upright with a strong spine tells your nervous system that it's time for alertness. This is because your brainstem integrates signals from the spinal cord to determine the body's orientation in space. If you slouch, your system shifts toward conservation. If you lean forward and plant your feet, the system shifts toward activation. This physical input helps your brain decide, do we prepare for action or do we rest? You can use this deliberately. Assume a focused posture, eyes forward, neck aligned, shoulders back, and you will feel your attention increase. Not because you're faking it, but because you're feeding your brain information it uses to regulate arousal. Now, let's talk about task architecture. One of the biggest mistakes people make is sitting down with an ambiguous or undefined goal. The brain thrives on clarity. When you don't know what your target is, your attentional systems remain diffuse. They search, they wander, they burn time. But when you give your brain a clear, single objective task, write 200 words, solve this one problem, complete this design frame, you reduce uncertainty and the focus system engages. This isn't just psychological, it's neurobiological. The more tightly defined the task, the more acetylcholine is funneled into the specific cortical areas involved. The brain says, this is what matters, and dials down distractions. This is why behavioral rituals before focus blocks are so effective. When you always sit in the same chair, wear the same noise-canceling headphones, turn on the same lamp, and open the same app or document to begin, you're training your brain to associate that context with focus. Over time, those cues become triggers. The moment you step into that configuration, your brain begins preparing for cognitive effort. This is known as context-dependent memory, and it's powerful. You don't just remember better, you focus better when the conditions around you are consistent. But there's another side to this. If your workspace is cluttered, if your phone is visible, if notifications are active, your brain has to use energy to suppress those distractions. And suppression is expensive. The prefrontal cortex can only inhibit so much before it fatigues. So the best move isn't to fight distractions. It's to design them out. Put the phone out of view, shut unnecessary tabs, reduce noise variability. You want your environment to whisper to your brain, this is a place of focus. Temperature, too, plays a role. Colder environments tend to increase alertness. When you're slightly cool, the body becomes more alert and responsive. Heat, on the other hand, induces drowsiness and can pull the system toward rest. You can use this lever depending on your needs. Want to get into a flow state quickly? Drop the room temperature a few degrees. It's a subtle push, but it makes a difference. Then there's movement breaks. After about 45 to 90 minutes of focused effort, what aligns with your brain's natural ultradian rhythm, you'll feel a dip. That's not failure. That's biology. Stand up, move your body, step outside into sunlight if possible. Movement resets norepinephrine. It restores dopamine availability. It re-engages your focus circuits without having to start over from scratch. The key is short, intentional movement, just enough to clear the cognitive cache, not so much that it drains energy. All of these environmental and behavioral levers are forms of instruction. Every light you turn on, every noise you reduce, every step you take to define your task more clearly, it's all part of how you speak to your nervous system. And your nervous system listens. It adapts. It predapts. It prepares. You're not trying to force your brain to focus. You're creating the conditions where focus is the natural, effortless response. The switch is not in some distant part of your willpower. The switch is already built in. You just need to set the stage so it can turn on. So now you understand, focus isn't about waiting for the perfect moment or hoping motivation shows up. It's not a trait that some people are born with and others aren't. It's a system, a biological, trainable system that you can control with precision. You've learned how your brain's attentional circuits work, how norepinephrine and acetylcholine act as the internal switch, and how to initiate that switch through science-backed protocols like visual anchoring, breath regulation, and aligning your effort with ultradian rhythms. And beyond that, you've learned how to shape your environment and behavior to signal your nervous system that it's time to engage, time to produce, time to lock in. This is how peak performers operate, not through luck or sheer discipline, but through strategy, through biological alignment. They work with their nervous system, not against it. And now you can too. You have the tools. You have the understanding. The next step is actions, because every time you apply these principles, every time you flip that switch on demand, you're not just improving focus. You're training your brain to respond. You're building circuitry that supports attention, deep work, clarity, and ultimately mastery.